The sign conventions of mirrors are going to be common to both. Okay, so what we are going to do is, we are going to consider a graph. Basically, graph consists of x and y axis, positive, negative. Correct? Say for example, this is going to be x, this is going to be x dash, this is going to be y, this is going to be y dash. So what we are going to do is, we are going to place the pole of a mirror in the origin like this. Let me consider concave mirror for this case. Okay, so whatever parameters we are going to have on the left side are going to be negative. Correct? So this is going to be negative, this is going to be positive, this is going to be positive, this is going to be negative. Say for example, if I take an image characteristics for an object which is placed beyond C, right? So where the object, where it is going to be beyond C means it will be between C and F. Correct. So if this is going to be C, this is going to be F, so it is going to be between C and F, this is going to be object and image. Now this object, let me take the height of the object as HO or H or H1, whatever you have your parameter, you can take it. I take it as HO. Okay, so where HO is considered to be height of object, right? And then HI, height of image, and the distance between the object and the pole, object distance, U. So U is considered to be object distance. And then the distance between the image and the pole is considered to be V, which is image distance. And the distance between F and P, we call them as focal length, F. Okay? The distance between the center of curvature and the pole is considered to be R, radius of curvature. So these are the parameters which we are going to deal with. Okay, height of the object, height of the image, object distance, image distance, focal length, radius of curvature. Okay, what we are going to do with this is, we are going to use signages for this. What signages? Say for example, HO is going to be the height of the object which is along the positive y-axis. So HO will be positive. The value of HO will be positive. Okay. In the case of image, the height is going to be inverted, which means what? It is going to be along negative y-axis. So height of the image is going to be negative. Clear? It is not going to be in all the cases. We have considered an example where we have height of the image to be negative since it is inverted image. Okay, right. So what will be the case for object distance? The object distance is again along the negative axis in front of mirror, right? So negative axis, so it is going to be negative. Object distance will always be negative irrespective for any kind of mirrors or lenses, because you are always going to place it in the negative x-axis only, in front of the mirror or lens. So it is going to be always negative. Okay, right. How about the image now? Image distance is going to be again negative because it is along the negative x-axis. How about focal length? Again it is going to be negative because it is along negative x-axis. How about radius of curvature? Negative. Clear? Okay. Suppose if it is going to be concave, the parameters are going to be same, but the sign conventions will vary. Because in that case, the image will be formed in virtual focus. So the focal length will be positive. Radius of curvature will be positive. If it is erect image, then height of the image will also be positive. Yes or no? Right? So that is how the sign conventions are going to be working out. So based on the positions and locations and the sizes of the objects and images, the sign conventions has to be implemented. Okay. Okay. In what way we are going to use this? See, we have something called as mirror formula, magnification. So we are going to use that, this sign conventions in that.